The last topic we have in kinematics is two-dimensional motion under constant force. Two-dimensional motion under a constant force. Two-dimensional motion under a constant force, and it's considered a kind of motion or a kind of translational motion, the motion between 2 points but in a curved line, in two dimensions, x and y. So if we have a graph, we represent x and y, and here is the velocity, and here is time, and we are going to try to describe the kind of motion if the motion is in curved line like this, smooth curved line, and we have the initial velocity. Here is the initial velocity, okay, and the magnitude. Here is the initial velocity u, and so the initial velocity makes an angle theta with horizontal, and we are going to resolve this velocity into components perpendicular to each other, ux and uy. Inshallah, I'm going to make a lecture for vectors and for resolving vectors or addition of vectors. Here is the initial velocity was u in angle theta. Since the object is projected with an angle, the object will move in a curved line. So we can resolve this velocity or initial velocity into component, initial, horizontal and vertical components. So for ux, you will find that ux is equal to u cosine theta, and uy is equal to u sine theta. What is required in this problem? The examiner may ask us for calculating the time to reach the maximum height. So for calculating the time to reach the maximum height, here is the maximum height, and also we are going to work to find maximum height h max. The time to reach the maximum height, we are going to use the first equation of motion. Of course, the object is moving under the effect of the gravity, so we are going to find it by using the uniformly accelerated equations. We are going to use the first equation. V is equal to u plus gt. What is the final velocity? Final velocity here, we are going to calculate final velocity, final vertical velocity. So Vy, and final vertical velocity is 0. Since we have an object and the object is moving upwards, as we mentioned before, the final velocity is 0. So here we have 0. What is the initial velocity? Which initial velocity we are going to use? Ux or Uy, since we are talking about moving upwards against the gravity. So U is equal to Uy. And what about g? G is equal to negative g. So let's substitute. 0 is equal to u, which is uy. G is negative g times time. And we are working for calculating the time to reach the maximum height. So t is equal to, I'm going to rearrange the equation before putting t at the subject. I'm going to move uy in the other side. I'm going to change the sign. So negative uy is equal to negative gt. I'm going to multiply both sides by -1. So to find t is equal to uy divided by g. By knowing the horizontal, the vertical component for the initial velocity and the free fall acceleration, of course, which is constant 9.8, we can calculate the time to reach the maximum height. Of course, the object while moving upwards is under the effect of the free fall acceleration, while it's moving in the second half downwards is by the effect, under the effect of the free fall acceleration. So time is constant. So t to go to the maximum height is equal to t to return back from the maximum height. So if I'm going to find t for the journey from the beginning till the end, t is capital is equal to t 2 times t small. We are going to use it later. What if the examiner is asking for calculating the maximum height? So we are going to work out for calculating the maximum height. Calculating the maximum height. For calculating the maximum height, we can use this equation. The second equation is equal ut plus half gt squared. S is the maximum height, so S is equal to h max. U is the initial velocity and the initial vertical velocity, so U is equal to uy. T is the time, we can calculate it from before, and G is equal to negative G. So S is h max, or maximum height, is equal to uy times T plus half, it's moving upwards, so it's not plus, it will be minus half g t squared. We can find the maximum height by using this equation, or another method for calculating the maximum height. We can find it like this: v squared minus u squared equal 2gs. You know that the final velocity is 0, since we are going to find the maximum height. Initial velocity is uy. G is negative g, so negative u squared is equal to negative 2 gs. So for calculating the maximum height, S the maximum height, S is equal to negative u squared over negative 2g. I'm going to remove the negative sign, so we will cancel it out. So S is equal to uy squared divided by 2g. If the examiner is asking for calculating the range, if the examiner is calculating the range, if we return back to the graph here, you will find that the horizontal velocity, which is horizontal initial velocity ux, is the same like the final horizontal velocity, because it is not affected by any kind of forces. What will be affected is the vertical component. So from the beginning here, the initial horizontal velocity ux is the same like the final horizontal velocity, stay the same, ux. So here even ux, the length of the vector represent the magnitude of the vector, so the horizontal velocity stayed the same, since it is not affected by any kind of force. But what about the initial velocity? The initial velocity will be less, will be very high in the beginning. It's very high, and then it will decrease a little bit until it will be 0, and then it will increases again to be the maximum at the moment before it touched the ground. But the horizontal velocity stayed the same. If the horizontal velocity is constant, we are going to use the normal equation, or the ordinary equation for calculating the range, which is v is equal to t divided by t. D is the range, t is the total time for the flight, v is ux or vx, it doesn't matter since it is the same. So for calculating range is equal to, we are going to make a cross multiplication. Range is equal to ux times t capital. T capital is the time of the flight in second, ux is the initial horizontal velocity, or the horizontal component for the initial velocity in meter per second, and of course the range is in meters. So if the time is in second and the initial velocity is in meter per second, the time will be in meters. Another case, if we have a cliff and we have an object that thrown from the top of the cliff, what will happen? Here we will have something else. We need to know the vertical component, the vertical height. So we have SV, and the horizontal displacement, which is SH. The horizontal velocity will stay constant, as we said. So if we have ux here, and here we have vx, so ux is equal to vx. the horizontal velocity stayed the same all the time. What will change is the velocity. Here is the initial vertical velocity uy equals 0, and then uy will start increasing gradually. At the moment before it touches the ground, it will be the maximum. Here is vy and here is vy. Okay guys, if and also we have the time, my dear students, we have the time. We can calculate the time by using the first equation of motion. V is equal to u plus gt. The object is under the effect of the gravity or the gravitational field strength, which is g, for calculating the time, and the time stays the same. Time is a scalar physical quantity. So if we are going to use the vertical component, if we know the final vertical velocity and the initial vertical velocity, which is 0, and by knowing of course g, we can calculate the time, or we can use this equation for calculating the time. S equal ut plus half gt squared. Since the initial vertical velocity or uy is 0, and we are going to calculate the vertical displacement, so SV is equal to half times g times time squared. So by knowing the time, we can calculate the vertical displacement. If we are going to calculating or try to calculating the distance from the base or calculating the horizontal displacement, we can find it by multiplying the time by the horizontal velocity, horizontal final velocity, or horizontal initial velocity. It doesn't matter since the initial velocity is constant, so we can use this equation. And also we can find the time by knowing the horizontal displacement and the horizontal velocity. We can calculate the time, and we can use the time here to substitute. So time is a scalar physical quantity, so if we are using the vertical equations for calculating the time or the horizontal equation for calculating the time, it will stays the same with us. And I promise you we are going to solve for past papers for two-dimensional motion under a constant velocity. Until I meet you again, I wish you all the best.